Good afternoon to all. So this is regarding to the computer network subject as part of the SRIT R20 syllabus. The first unit regarding to introduction to computer networks. It is basically divided into two portions. One is the introduction portion and followed by the some of the models and physical layers. So in this video, I'm just briefing the contents of the complete all the 5 minutes regarding to the SRIT R20 syllabus only. You know very well about regarding to the computer. Computer is nothing but the combination of the software and hardware. Similar way, computer networks is nothing but the combination of the intermediary systems. All the systems are connected to share the information, whatever it may be. So in this case, each and every device you can call it as a host. That is called as the computer network. And these are the some of the applications of the computer networks, business applications and home applications, mobile users, social issues. So these are the some of the applications are there. There are so many applications are there, but these I mentioned only few applications. Coming to the first one is business applications. Under business applications, there are so many categories are there. First one, resource sharing and virtual private networks, client server model, communication medium, and IP telephone and e-commerce. You know, the resource sharing is nothing but we can share the resources. That may be file, that may be information, that may be devices. Anything can be we can share if our device is connected into the network. And next one, virtual private network. Majorly, this is used for to secure the network. Whatever the data you are sharing, you share that network in a secure manner. For that purpose, you are using the VPNs. And client server model, client is requesting something, and similarly, server is also given the same response to the clients. Such a model you can call it as a client server model. And communication medium, you know very well about the email service. Email service is one of the powerful communication medium. And IP telephone. So nowadays we're using the VoIP, Voice over Internet Protocol, which means every device is going to be connected into the IP address. Every device is working with the based on IP address only. That's why all the telephone lines become nowadays into the IP-based systems. And the last one, e-commerce. E-commerce websites are also there are so many websites are there. E-commerce platforms. Every e-commerce platform is used to by selling and buying. Everything is going on. In this part, there are so many categories are there: business to consumer, business to business, consumer to consumer. So these are the some of the models we are using in the e-commerce. And the next application, which is called as the home application. The first one is the access to remote information. So we can access any kind of data. So you can do the shopping and paying the telephone bill, e-banking, online share marketing, digital library. There are so many things we can approach the internet, person to person communication. The best example is the social network platforms, Twitter, Facebook, everything. They are also using the computer network and interactive entertainment. So IPTV, every home is converted into internet protocol television. And one more thing, nowadays we're using the OTT platforms. So we can watch the movies by using such platforms. For that purpose, we're using the over the top. Mobile users, wireless sensor network, and global position systems, so we can identify, track the device throughout the network where it is there. And NFC, near field communication. This is also one kind of communication. We can communicate with the small gadgets. The social issues, the last one is the social issues, network neutrality and profiling users, phishing. These are some of the uses of the computer network. Next one, network hardware and as well as the network software. Coming to the network hardware, it is divided into two components. One is the transmission technology, and second one is the scale. The transmission technology is nothing but so how you are connecting the devices. So how can you transmit the data between two devices? That is the physical medium. There are two types of transmission technologies are there. One is the point-to-point links and broadcast links. So point-to-point link is nothing but one sender sending the data. Exactly one receiver is going to be receiving the data. This process you can call it as a unicasting. Broadcasting is nothing but one sender sending the data. All the receivers are receiving the data. That is called as the broadcast. That broadcast, one more terminology is there, which is called as the multicasting. Multicasting means one sender sending the data, only selected recipients receiving the data. That is called as the multicasting. And coming to the scale, which is focus on so how large your network is going to be spreading. That may be 1 meter, 10 meters, like that. Based on geographical locations, we can divide network into personal area network, local area network, metropolitan area network, wide area network, and last one is the internet. So if you connect devices between 1 meter, those we can call it as the personal area network. The best example for the personal area network is the Bluetooth. Local internet network is nothing but you can connect the devices within a room, within a building to share the resources. So, like that, based on geographical locations, you can change the data from, you can establish the networks with the different geographical locations. And next one is the coming to the network software. Network software is nothing but the protocols, what kind of protocols are you using, so how each and every protocol is going to be working. So entire network is divided into some layers to reduce the design complexity. So in this case, majorly we're using the layers and the gap between the each and every layer, we can call it as a distance. And protocol is nothing but the rules and regulations or agreement between the two communicating parties, we can call it as the protocol. And connection oriented service versus connectionless services. Connection oriented service, the best example is the telephone system. In that, for example, we want to make a call to the someone else. First we have to make a call, dial by using any one mobile number. If the connection has been established, then you can start the conversation. After completion of the conversation, again you can disconnect the call. This is called as the connection oriented service. The best example for the connection oriented service is the circuit. In connectionless service, the best example is the called as the postal system in the real world. The packet switching is called as the best example for the connectionless service. In this connectionless service, they don't want to bother about uh, connection establishment. Just we have to transmit the data without any confirmation from the receiver end. So these are the some of the service primitives are there. Service primitives is nothing but some operations, available operations to access the services. Listen, connect, and accept, receive, send, disconnect. These are the some of the services we are using in this case. And next one, entire computer network follows some layers. Majorly, we're using the two reference models. One is the OSI reference model and TCP reference model. The OSI reference model is used for studying purpose only. So we are unable to implement this model. This model also called as the OSI ISO OSI reference model, International Standard Organization for the Open System Interconnection. The main motto of this layer is so how the two remote devices are going to be communicating with each other. That's why we are designed one model which is called as the OSI reference model. It has 7 layers. 7 layers. The first layer, both the sides. So I'm talking about 7 layers. These 7 layers. So here, let us assume this is the sender end. sender end, and this is the receiver end. This is the receiver end. For example, sender wants to communicating with someone else. Sender wants to communicating with someone else with a friend or a system. First, he is going to be communicating with the first layer, which is called as application layer, followed by the presentation layer, and session layer, transport layer, network layer, data link layer, and physical layer. Finally, you can transmit the data from the physical layer to the second end receiver end device physical layer. So this process we can call it as encapsulation. This process we can call it as the encapsulation. Each and every layer we are adding something, and this process we can call it as a decapsulation. This is called as a decapsulation. We are removing some data once we are left from one layer to the another layer. In this application layer, in this application layer, majorly, so this is physical layer, and coming to the bottom layer, physical layer is used to transmit the data in the form of bits, by using the physical medium, So we can transmit the data in the form of either mechanical or electrical or timing interfaces in the physical medium. You can transmit the data in the form of physical medium, that may be 0 or 1s. Next layer, top of the physical layer, we can call it as the data link layer. In the physical layer, data should be, we can call it as bits. Coming to the data link layer data should be in the form of frames. Data should be in the form of frames. So data link layer is used to create frames. Data should be in the form of frames, and we can transmit that into the next layer. So these are some of the services are there here. The first service you can call it as framing, try to create the frame, and next one is the physical address. You can call it as a MAC address, physical address, which is called as a MAC address. And the next one is the flow and error control. The flow control, error control. Flow control is different from the error control, and access control is also different. So these are the some of the services are there in the data link layer. Coming to the network layer, in the network layer, the address should be logical address, which is called as the IP address. We are using in this case, we are using the IP address. We are talking about IP address. In the data link layer, we're talking about MAC address. So network layer is used to perform the routing between the two layers. Routing between the two layers. The address we can call it as a logical address, which is called as the IP address. These are the two services. Coming to the transport layer, in the transport layer, the data should be in the form of port address. We're talking about the port address. These are the some of the services are there in this case. One is the port address, and segmentation and reassembling, connection control, and end-to-end flow control, error control. These are the some of the services in the transport layer. So I am explaining with small example regarding to the addresses. So IP address is nothing but in general reaching our city, and MAC address is nothing but reaching our apartment. Port address is nothing but reaching right person or right person or right door. That is called as the IP address, MAC address, and port address. MAC address at the data link layer, IP address at the transport at the network layer, port address at the transport layer. Coming to the session layer plays an important role. The session should be active during the data transmission. So here also some of the services are there. One is the dialog control, token management, and synchronization. These are the important services are there in the session layer. And coming to the presentation is nothing but so how your data should be syntactically and semantically. Syntactically as well as the semantically you can transfer the data. Syntax means the and semantic meaning of the data. So you are sending the data at by using which syntax? That may be different forms, video format, audio format. Generally, you can call it as a MIME format. So, multimedia data transmit, you can call it as the MIME format. Presentation layer has some services. The first one is the translation. The first one is the translation. And second one is the encryption and decryption. And third one is the compression and decompression. So these are the some of the services are there in the presentation. Coming to the application layer plays an important role. This is very closer to the user. So in this case, you can use so many protocols, HTTP protocol and HTTPS protocol, FTP protocol, SMTP protocol, POP3 protocol, IMAP protocol, Telnet, DNS, and real-time protocol. These are the some of the protocols we are using, and widely using protocol is called as HTTP. This is one scenario. So how your data should be communicating two devices with each other. In this case, the first three layers commonly we can call it as the first three layers. In the first three layers, the data we can call it as the data. Whatever the data you're transmitting, the data we can call it as the data in the first layer. And coming to the coming to the transport layer, data should be in the form of segments. The data should be in the form of segments. So whatever the data received from the top three layers, you can convert the data into in the form of segments. Segment is nothing but data plus a header. Segment is nothing but data plus a header. That header contains sequence number as well as the source port number as well as the destination port number, and you can use any one protocol. Because in the transport layer, we are using the majorly two protocols. One is the TCP protocol and UDP protocol. So you can send the data in the form of segments. Segment is nothing but a data plus a header. The header containing the sequence number, source port number, destination port number, or any one of the protocol. So if it is a TCP, then you can use the TCP protocol, which is connection-oriented protocol. You can use the TCP protocol, or connection-less protocol. You can use the UDP protocol. That is called as a segmentation. And you can transmit data from the transport layer to the network layer, which is segment. Now, the data should be in the form of packet. The data should be in the form of packet. At which layer? To the network layer, you can call it as the data should be in the form of packets. What the packet will consist of? The packet will contain the segment. The earlier layer data will be called the segment and followed by the header. Again, what do you mean by header? Source IP address, destination IP address, and protocol number. Protocol number we can include it. Now we can transmit that packet into the next layer, which is called as the data link layer. The data link layer data should be in the form of frame. That should be in the form of frame. Again, frame is nothing but collection of packet plus a header. The packet is which is from earlier layer plus data header. So header is nothing but source MAC address as well as the destination MAC address as well as the type field. Now we can send the data into the next layer, which is called as the physical layer. The physical layer data should be, we can call it as the bits, zeros and formats. Now we can transmitting this complete information via physical layer. Now we can receive the data at the physical layer. Now you can apply at the reverse process. You can bits are going to be converted into frames, frames are converted into packets, and packets are converted into segments, segments into data. So like that you can transmit the data between the two. Similar way, one more reference model is important, the TCP IP reference model. The TCP IP reference model, this is the model after designing one important network which is called as an ARPANET, Advanced Research Agents Network, which is used to developed by the US Department of Defense for connecting the universities and government offices. So here there is some drawback is there. Unable to install or work with the satellites and radio networks which are there in the existing. Why? Because the every moment, every time we have different components. The installation process is very difficult in the uh, existing protocols. That's why we are moving from the one more architecture which is called as the TCP hyperreference model. This TCP hyperreference model only containing the four layers: application layer, and these two layers are not present in the TCP hyperreference model. So the first three layers we can call it as application layer. Transport layer is as it is. Network layer we can call it as the internet layer. Data link layer we can call it as a link layer. So these two layers are merged and we can call it as a link layer. So this is regarding to the TCP hyperreference model. Same thing, whatever you're doing in this case, the same thing again. Application layer, there are so many protocols are there. The transport layer, we're using the TCP as well as the UDP protocols. In the link layer and as well as these are the some of the TCP IP reference model. And coming to the next portion, which is called as the transmission media. Transmission media is nothing but you can transmit the data either guided or unguided medium. Guided means through wired, unguided means wireless media. The guided media, we are transmitting the data in the form of the twisted pair, like coaxial cable or fiber optics. In case of unguided media, we have so many possibilities are there: microwaves, radio waves, cellular waves, and infrared and satellites. These are the some of the mediums you can transmit the data from the source to the destination. The first one we can call as the twisted pairs, and we know very well about the twisted pairs. Twisted pair contains two conductors, each with its own plastic insulation and twisted together. One of the wire is used for carrying signals to the receiver, and other one used for ground reference. Other one used for ground reference. So generally, which is a 1 mm thickness, and it is looks like a DNA module, and next one is the when the wires are twisted, the waves from the different twists cancel out, and so that wires radiation is going to be less effectively. And twisted pairs are again two types. One is the unshielded twisted pair and shield twisted pair. The best example for the shield unshielded twisted pair we're using in the telephone communication for both voice as well as the data transmission purpose. So these are the some of the cables are there, category 1, 2, and category 7. In the each and every cable, the data transmission rate should be different. The data transmission rate should be less than 0.1 Mbps. You can use the category 1, and the data transmission rate should be 2 Mbps. You can use the category 2, and so on. If the data transmission rate should be more than 200 Mbps, you can use the category 7. And the category 7, we're using the gigabit Ethernet, which is called as a shielded twisted pair. Remaining all we can call it as a UTP, unshielded twisted pairs. Coming to the coaxial cable, the coaxial cable is also one more physical medium transmitted the data through the cable, coaxial cable, and this this has two kinds of varieties. One kind we can call it as a 50 ohms cable, which is commonly used when it is intended for the digital transmission from the start, and one more thing, 75 ohm cable, which is for the analog transmission purpose reason. So this is regarding to the coaxial cable. And coming to the switching, in computer networks, switching refers to the there are two cases. One is the circuit switching and as well as the packet switching. The circuit switching entire process is going to be divided into pieces. Each and every piece we can call it as a bit delay constant, and we can transmit. The best example for the circuit switching is the telephone networks. The telephone system is going to be working based on the switching, circuit switching, and we can transmit the data, send the data and voice and video in the case. This is called as the circuit switching. The circuit switching, first you have to establish the connection, then you can transmit the data and you can close the connection. Coming to the packet switching, the best example for the packet switching is the we can transmit the data, store and format. This is also one kind of connectionless switching, and packet switching is going to be looks like this case.